Hey, these are notes 5.7. We're going to calculate some probabilities and go opposite again, except it's not on a normal curve. So it's kind of the same idea as what we did yesterday, but it's not on the standard normal curve, it's just on a normal curve. So which means we're going to have, like, for example, the test scores we talked about one time had a mean of this and a standard deviation. So what if somebody scored, what's probably somebody scored less than a 4? Okay, so 4 would be somewhere here. It's not on one of these things to use the 68, 95, 95, 9.7 rule. So we're going to figure out how to find that probability. Okay. Remember we said I showed you on how to do it on Desmos for the normal curve, but if it's not, standard curve, but if it's not standard, okay, if it's not 0 and just 1, then I'll show you two different ways of doing it. Okay. So the way we're going to do that is I'm going to give you an example here. Okay, so Rory McIlroy. Okay, I'm not familiar with golfers, but anyway, he's a golfer, good golfer. He practices his swing with a particular club by hitting many golf balls. So with one certain club, he's got to know how far it's going to go with that club. So X is the distance the ball travels on randomly selected shots with his driver. Suppose it follows a normal distribution with a mean of 304 and a standard deviation of 8. Okay, so if you remember how we set this up, okay, the 304, if I go one standard deviation away, I add 8, which is 312. If I go two standard deviations away, I add another 8 to it, which is 320, and 3 standard deviations away, add another 8, I got 328. Okay. Go the other direction, 304 minus 8 gives you your 296, minus 8 more is 288, minus 8 more is 280. Okay, so you could do one of two things. Okay, so we want to know our probability of X is greater than or equal to 290. So what's the probability that he's going to hit this golf ball 290 yards or more? Okay, so two different ways of doing it. Okay, method 1. This is before technology, this is how everybody did it. Okay, so 290 is, about right here, right? So we want to find this area in here, greater than 290. So that's our goal, to find that area. So method number 1 is they converted it to a z-score. Okay, so his score was a 290. The mean was 304, and the standard deviation was 8. Okay, so I know his z-score is going to be negative 1 point something, right? So it's negative 1 point something there. But if I work that out, okay, I take that 290 minus the 304 divided by 8, I get a z-score of negative 1.75. Okay, so now 1.75, and I want to get up here. So now you can go on to Desmos, right? And find the normal distribution. And remember, you check that box there, right? And we would have a minimum of negative 1.75. And we would do a max all the way out through infinity. Okay? And it would give us, let me pause this and put it on Desmos and see. It would give us 0.96. Okay, so that's one way to find it. Okay, so convert it into a z-score, and then just use the normal distribution. Don't change anything here. Use that 0 and 1 in Desmos, and find your min and max. Okay, now I'm going to show you method number 2 in Desmos, where we don't change it to a z-score first. Okay, so I'm going to stop this video, go to Desmos, and pop that in here. Okay, method number 2, to not turn it to a z-score first. We still do the same thing. We go here and go to normal distribution, except instead of using a mean of 0 and a standard deviation of 1, we're actually going to put these numbers in. So he's hit it a mean of 304 yards, comma, and the standard deviation was 8 yards. Okay. Now if I hit this zoom fit, now we get a bit of this graph here. We got our mean here at 304 and the standard deviation stuff here. Okay. Now we want to know the probability that it's greater than 290. So we want to know from 290 through infinity. So from 290 through infinity is your 0.96.
Okay. The other way we did it before, okay, method number 1, I'll show that to you real quick. We kept the 0 and 1 there, and we found a z-score of negative 1.75 through infinity. Notice it's the same thing, right? Okay. So those are method 1 and method number 2.
Okay, another example for us to do is, looking at that same example, but what percentage of his drives are between 305 and 325? Okay, so if we look at the graph here, 305 is about right here. 325 would be about here. So we want to find this area right in here. Okay, so once again, 2 different ways to do it. I think method 2 is probably the easiest to not turn them into z-scores. So I will real quickly show you how to do that on Desmos to find the area between those two. So we want the probability that it's between 305 and 325. Okay.
Okay, so to be between 305 and 325, once again, functions, normal distribution. Okay, instead of z-scores, instead of 0 and 1, I'm going to put in what he did. He had 304 as his mean and 8 as his standard deviation. And we want to know between minimum of 305, maximum of 325. To find the area between those two, it gives us about 44.6. Okay, 44.6.
The next example here, according to the cdc.gov growth charts, you can actually look up your percentage and stuff, but anyway, the heights of 3-year-old females are approximately normally distributed. So 3-year-olds, normally distributed, with a mean of 94.5 and a standard deviation of 4. So 98.5, 102.5, 106.5, subtracting 4 gives you 90.5, subtracting 4, 86.5, and 82.5. Okay, so it says 75% of 3-year-olds are taller than what height? Okay, 75% are taller than what height? Now I don't know exactly where it is. I'm just going to I'm going to estimate maybe it's here. Okay, so this right here, this would be 75. So 75% are taller than what height? We got to find out what height here. Okay, which means on this side over here, if the 75 are taller than what height, this would be 25% that would be smaller than that height, right? Okay, so we're going to, just like we did yesterday when we did the inverse, we're going to do that inverse again. Okay, so we got to find this number right here. So I'm going to show you on Desmos how to find that.
Okay, so we're going to go here to normal distribution. You could turn it to a z-score, but we're not going to. I think it's easier to just do this. It said the average height, the mean height was 94.5, comma, and the standard deviation was 4 inches. Okay, so here is that distribution. Okay, now if we want to find a certain percentage below and above and so forth, but we're trying to find the percentage here. So what we're going to do is we're going to put dot, and we have to do the inverse now. So the inverse CDF, and it's always the area to the left. So I have to put the 0.25. 75 is to the right, and to the left would be 25%. So the height would be at 91.8. 91.8 inches would be where 75% would be above, 25% would be below. Okay, we can kind of check ourselves here with this too. Okay, if I just do normal with that 94.5 comma 4, and if I check it, okay, at 91.8 and above, right, and it's our 75%. Okay, so if somebody is 91.8 inches, they're in the 25th percentile, which means 75% would be taller than them.
Found that to be 91.8, so it's actually over here. Okay. Okay, so last problem we're going to do together. High levels of cholesterol in blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal with a mean of 170 and a standard deviation of 30. So if I add 30 30 and add 30 and subtract 30, subtract 30 and subtract 30. Okay, so I got it drawn out here. Okay, so number 1, cholesterol levels above maybe require medical attention. So what's the probability there's a 14-year-old boy that has a cholesterol above 240? Okay, cholesterol levels between 200 and 240 are considered risk for heart disease. So the probability that somebody's at risk would be between 200 and 240. And then part number 3, what cholesterol level would place a 14-year-old in the 10th percent of the distribution? So 10th percent means the 10th percent would be there, 10th percentile. So we want to know that number right there. Okay, so we're going to go to Desmos and work those 3 things out. So copy those down and make sure you have those.
Okay, so to get a look at the graph, let's go to functions, distribution, normal distribution. And the mean cholesterol was 170 with a standard deviation of 30. Okay, hit the zoom fit. There's our little graph. Okay, so we want to know, first of all, above 240. So above 240 is dangerous. Okay, so if we go here above 240, so 240 and a max above. Okay, so that's that area right there. So it's 0.0089. So almost 1% of 14-year-old boys would be considered dangerous there. Okay, number 2, what percent were considered high? So between 200 and 240. Between 200 and 240 give us about almost 15%. So 14.8, 14.9%. Okay, and then the third one is the 10th percentile. Okay, so I want to know, where does this here give me 10% below? But what value? So remember, we keep this. We put the dot, the period, and then we put our inverse in there. So we're going to find the inverse, and we want the 10th percentile. So at 131.55. Okay, double check ourselves here. Okay, and find the cumulative from negative infinity to 131.55 gives us 10%. We're really, really close. Okay, 10% right there would be at that area. So lower 10 percentile would be 100 cholesterol level of 131.55.